Hello. So in response to the needs of one of my students, I'm going to talk through how you analyze a database from clinical research. So we're going to go through the very basics in this first tutorial, and I'm going to talk about how we do that in Microsoft Excel. So here you can see on the screen, we've got an example of a data set completely made up. It's fictitious, but here we've got the number of the patient that we've assigned, the date that the patient was recruited to the study, and the patient's date of birth. We've then got a gap for the age that we've got to calculate. And then we've got some characteristics here. So male sex, hypertension, hyperlipidemia, diabetes type 1 and diabetes type 2, and a little bit of missing data that we'll come to later. So we need to now summarize these data. We're going to basically summarize the demographic characteristics of the patients that are in this sample. So we've got Excel. First thing that we're going to need to do is fill in this gap for the age. So to do that, we're going to need a formula. We've got the date and we've got the date of birth. Essentially, what we need to know is how long elapsed from this date, the date of birth, until this date when we recruited the patient. So it's a simple difference. If we calculate equals, Excel knows that we're trying to get it to do a calculation. And then we put in the cell references of the values that we want in this calculation. It will calculate it for us. So equals B2, and that's the date. So the difference between B2 and C2, the date of birth. And that will then give us a value. Here we can see 31,639 doesn't mean a lot to us. So we need to calculate that in years. In fact, it's given us that in days. So we now need to convert it. To convert it, we just go back into the formula editor, and let's put some brackets around that calculation, and then divide the whole thing by 365. And that'll give us the patient's age in years. So now we have 86.68. Very good, very nice, precise age. We tend to only want it to the nearest year, or to the rounding down to the nearest whole year. So we need to add in something else. So we're going to add in a formula now. So go back into this formula, and we're going to need to find a formula that will round us down to the nearest whole number. If you don't know what that is, you can go here and bring up the formula search. So we can now say round down to the nearest integer or whole number. And then Excel will give us a number of different options that it thinks are relevant to it. So we've got round, or in fact, when we get to int, you can see this rounds down to the nearest integer. So we'll use that. I don't actually like using that, but you can use this and it will talk you through how to create the formula in the boxes. I prefer, once you know what the formula is, just to type it in. So you put equals, and then you put int, and then it's going to tell us the number that we want to round down, and we've already typed that in. We just need to put brackets around it, and then return. And now it's going to tell us the age to the nearest year rounding down. Then we've got to copy that. So if you use Control-C and then drag this down to the bottom, we've only got 20 patients in this data set, and use Control-V to paste. Now you can see we've got the ages for all the patients in. The rest of these are formatted well. Let's just talk through the formatting of the database, because there are some specific requirements for how you should format it. Here you can see we've got sex. I've put male sex, and there's a reason for that. I do research into acute coronary syndromes and cardiovascular disease. So for some of the more advanced features of the analysis, you need to think about what's the risk factor you're trying to predict. So if you're running a multivariate model, you need to be identifying what's the risk factor, and male sex tends to be the risk factor. So I ask each question as a yes or no. Does the patient have a sex that's male? And if they are male, we get a 1 for yes. And if they're female or other, we get a 0 for no. Then we've got hypertension, hyperlipidemia, diabetes, and type 1 and type 2. And again, if the answer is yes, they have that feature, then we get a 1. If it's a no, then we get a 0. So our database is now nicely formatted. We've got the missing values just as gaps here in the data. And now we need to work out some analyses. So I've created another tab here at the bottom called Analyses. And in that tab, I've now grouped the variables into continuous variables and categorical variables. So continuous variables can take any value whatsoever, whereas categorical variables can only fit into one or more categories. So age is a continuous variable because you can be any number with age, although we round it to integers. Whereas these others are all categorical variables. And in fact, you go further than that, you can see they're dichotomous because the answer can only be yes or no, arguably in most of these anyway. We've simplified things with sex. So then we want to think, how are we going to summarize those data? For age, how are we going to summarize it? So we tend to summarize that with the mean and the standard deviation. So let's work that out now. So how do we work out the mean? So if we're not sure about it, we start equals. Excel recognizes we need a formula, and we can insert a function, and then we can say mean average, and it will come up with this average. It tells us that we want average. If we click OK, it'll prompt us to find out, okay, you want the average of something, where are the numbers that it wants us to average? And we can put in the references here. So you can click this, for example, and we can go here. And I think if we select it all the way down, we should be able to drop it in. I don't usually like doing it this way. So we can do it that way. And I think that will do it. Yep, here we go. Okay, so now we've got the mean average of the age, as you can see. I'm going to type the next one in. So this one, we want a standard deviation, because that gives us an idea of the spread of the data, how widely spread are the ages of the patients. Again, if you're not sure, you can look this up. We can start typing for standard deviation, and you'll start to see the list of things that it thinks we might be typing, might be wanting to predict. And you can see we've got all of these functions. Now, stdev is standard deviation. It's an old function. That's why it's got an exclamation mark next to it. You've got these more up-to-date ones. I tend to just use standard deviation in this format. And again, we now need the range of the variables. So if we go back to data and we select the bottom of age, press shift up to the top, and you can see it's come up here. Let's close the brackets. And now it's going to work out the standard deviation of the age in between those variables. We might only want that to one decimal place. So let's right click, click on format cells, and let's go to, let's make it a number with one decimal place. Okay. So that's age summarized. Now let's move on to summarize these other categorical variables. And what we want to know here is how many in the cohort have each of these characteristics. So for sex, we said we were going to categorize it as male, sex, or other. And for this now, we're going to calculate another formula. And the one that I use is COUNTIF. So we want to count in a certain range the number of cells that have a particular value. So I'll show you what this does. So we're going to open the brackets. And now you can see it's prompting us to enter the range. So where's it wanting us to look? Or where are we wanting it to look? And we're wanting it to look here at the sex of the patients. So let's do that. It's appeared here. And what's the criteria? What do we want to count it? Well, we want to count all the ones, because we want to count all of the men, basically, all the male sex. So let's put 1 in here and then close the brackets. Enter. And you can see now it's calculated that there are 11 patients with male sex. Now we want to work out, well, what's that as a percentage of the group? So we now want to say B6, but we want to divide it by the denominator, how many people were in the database. So for this one, I'm going to use count A, which is basically counting the number of cells in that range that aren't empty. So how many cells have a valid value and therefore aren't missing, for example. So let's do that again. And you can see now we've got that. And I like, yeah, that's ridiculous. So now we've pressed enter there. I've formatted this as a percentage, which makes it nice. And you can see that there's 11 men, that's 55% of the total. And now we just need to know if there are any missing data, because that's important too. So let's use the COUNTIF function again. Let's get that range back, same range, down here. And this time we want to count it if there's no value, or if it's missing. And the way we do that is using 2 quotation marks. Press enter, and it tells us that for that, there's no missing values. Now you can see I've formatted this like this. We've got the categorical variables across as columns, and that is the same as we've got here. Now that helps us because we could just copy, Control-C, these formula values and translate them across. So here, paste them across, and it will shift the formulas. So we can see here, it was counting E2 to E21. When I've pasted it, now it's calculating F2 to F21. And you can see that corresponds to here. So this is the right column. We're looking at hypertension this time. And it does the same here. We look at column G, we look at column H. So it's done the right calculations for us automatically. And so we've done it. We can see there are 7 patients with hypertension. That's 35% of the total, no missing. Skip across to diabetes. There's 1 patient with type 1 diabetes. That's 5% of the total. And 4 with type 2 diabetes, which is 22.2%. So there we go. A quick way to calculate your demographics and summarize them in Microsoft Excel. And that's the basics